Hi, so let's continue our discussion on gradient descent, and in this video we will learn about steps involved in gradient descent algorithm. By the end of this video, you will be able to explain different steps performed in gradient descent algorithm. Now that you have understood the steps of gradient descent intuitively, let's have a look over them mathematically. Considering the same sale price and flat area problem that we have been dealing with in this module, we have two parameters, slope m and intercept c. We can always initialize them to a small random value, but initializing the intercept to mean regression model is considered better so that gradient descent will not have to start from scratch. Therefore, our initialized parameters can be slope m equal to 0.1, intercept c equal to mean of sale price. Step 2 would be to generate predictions using the initialized values. For that, we simply use the equation of the line y hat equal to mx plus c, where we have already initialized the values of m and c in the previous step. Note that we will be representing the predictions by the symbol y hat. Step 3. The next step is to calculate the cost of predictions with respect to the actual points. As discussed before, we are going to use the mean squared error as our cost function, and we will be representing the cost with tau. Now, if you look closely, the expression on the RHS is exactly the same as the mean squared error. But we know that y hat equal to mx plus c. Therefore, we can substitute this to obtain the result as shown on the screen, which means that the cost function depends upon the slope m and intercept c. Step 4. Now that we have calculated the cost, the next step would be to update the parameters. The updation of parameters is done as follows: m new equal to m old minus zm, c new equal to c old minus zc. So we can clearly see that the new parameters depend upon the old ones, but this quantity z is still unknown. But we can tell that z can either be positive or negative, and we can also tell that the sign of z will determine whether the parameter will increase or decrease. If z is positive, the parameter would decrease, and if z is negative, the parameter would increase. Now the question is how to find z. If you recall, the cost function curve with respect to a given parameter looks like this. For the sake of simplicity, we are considering the cost function corresponding to the parameter m only. Let us consider a case where the algorithm starts from the left side of the minimum, denoted by the yellow point. To reach the minimum, we clearly see that we need to increase the value of m, which means zm has to be negative. By doing that, we will move towards the minimum cost. Now consider the second case, where the current value of cost function is on the right side of the minimum cost. In this case, what do you think we should do? Clearly, we need to decrease the value of m, which means zm has to be positive. By doing that, we will move towards the minimum cost. But the question is how? How would we know on which side of the minimum cost we are on, and what value should we take for z? Say hello to partial differentiation. The best way is to use the method of partial differentiation. We are assuming that you are familiar with the concept of partial differentiation and what it is used for. On partially differentiating the cost function with respect to m, we get the slope of the cost function with respect to m. Now, if the value of the cost function is on the right side of the minimum, the slope obtained will be positive, as you can see on the screen. Similarly, if the slope is to the left side of the minimum, the slope obtained will be negative. So we notice that the sign of the slope will always be the same as that of the desired value of zm, and hence we can take this partial derivative or some modification of it as our zm, as we will shortly see. Now the partial derivatives of the cost function with respect to m and c are given as shown on the screen. Now we can take zm as alpha gm and zc as alpha gc. Therefore, we can write the formulae for updating the parameters as M new equal to M old minus alpha GM old, C new equal to C old minus alpha GC old, where Gm and Gc are the gradients of the cost function with respect to M and C respectively. Now, you might be wondering what the alpha is. Alpha is called the learning rate, and it is a constant that we set to a small value. It acts as the moderator to the process of updating the parameters, that is, it controls how big the change between old and new value should be so that we reach the minimum value gradually. To understand its effect, let's consider this cost function curve. If we assign the value of alpha to be significantly high, the parameters will be updated by a large value, and there is a good chance that the cost function explodes and bounces out far from the minimum. On the other hand, if we assign alpha a very small value, the parameters will take lot of iterations to converge to the optimal value. Hence, we take alpha neither very small nor very large. The actual value depends on the problem, and in case of our problem statement, we will take the value as 0.01. Once we have updated the values of M and C, we repeat the process and calculate the new predictions and new value of cost function. If the difference between the new value of the cost function and the previous value of the cost function is less than a threshold value, usually in terms of 10 raised to the power minus x, we say that the algorithm has converged and we can stop it. Else, we repeat the above steps till the time the algorithm converges. So that's it for this video. In the next video, we will understand how gradient descent is implemented in Python.